I'm gonna solve number 13 of the forces review worksheet. This is a level 3 question, and here goes a proposition of a work solution. So a bicycle takes 8 seconds to accelerate at a constant rate from rest to a speed of 4 meters per second. If the mass of the bicycle and rider together is 85 kilograms, what is the net force acting on the bicycle? Hint first, calculate acceleration. So, first of all, it is important that we take notes of the data given. So, the time it takes for the bike to accelerate it accounts for 8 seconds. It goes from rest, so the initial velocity is 0, and it speeds up to 4 meters per second. The mass of the bicycle together with the rider is equivalent to 85 kilograms. And the problem asks for the net force. So it is important to see that for you to calculate the net force in this context, you would have to have the mass and the acceleration. And the product of those two quantities would give you net force. However, we don't have the acceleration. So the first step to take in this problem is to then figure out what the acceleration is. We have enough data to figure it out, which is the initial velocity, the final velocity given, and the time it takes for the acceleration on the object to take place. So, if we use the Savat equation, V equals U plus AT, and plug in the values that are missing in order to figure out what the acceleration is, then we solve the first step of the problem. So, plugging in the values, we're going to have velocity equals to 4, initial velocity 0, plus acceleration times time. So this is a one-step equation. So we have this being as 8a equals 4, dividing both sides by 8. We're left off with 1 over 2, that is 0.5 meters per second squared. Given the acceleration that we have just figured out, we can now find that force since we have the mass of the system, bicycle and rider. So if we plug in the mass into m, we end up with 85 times 0.5. And calculating this, we end up with 85 times 0.5. That's going to give 42.5 newtons. Okay, so net force equals 42.5 newtons. It is important to highlight the final answer and make sure that you use the correct unit. Following, we have an air resistance case. And how do we solve this problem? So first of all, we need to first and foremost take notes of the data given to see what we have at our disposal and see what the problem is asking for. The problem goes like this. An object of mass 30 kilograms is falling in air and experiences a force due to air resistance of 50 newtons. So the air resistance is equivalent to 50 newtons. The problem asks for the net force of the system acting on the net force acting on the object, and the acceleration of the object. So in order to visualize and picture better the given circumstance, I highly recommend that you student design a free body diagram of the object. So the forces acting upon the object are the weight, the gravitational force, and also the air friction pointing up, which accounts for 50 newtons. The weight is calculated by mass times acceleration due to gravity, so the weight is going to be given by 30 times 10 meters per second. So that's going to give us 300 newtons. So that's what the weight is equal to. And in order to calculate letter A, we do the vector addition between air friction and the weight. So the forces acting upon the object are air friction. And before we go on with the calculation on that force, let's assume that the reference frame is pointing down. Okay? So everything pointing down will be equivalent, will be positive. So then we have the weight being positive, and then air friction as being negative. Simplifying this, we end up with 300 minus 50. So the net force acting on the object is equivalent to 250 newtons. So as for letter B, it asks for the acceleration of the object. We know the net force equals ma. Since we have the net force, which is equivalent to 250, the mass of the object, which is 30, we can then calculate the acceleration. And that's going to be, if we divide both sides by 30, we isolate A. And we are left off with 250 divided by 30. We cancel the zeros, and so if we divide 25 by 3, we end up with 8.3 meters per second. Let's round it off to 1 decimal place. And this is what we're going to have. Okay, so thanks for watching, and stick around for more problems, more work solutions that are coming up for level 4 questions. See you in a bit. Bye bye.